Hi everyone, welcome back to Infinite Math Help Squared. This video is going to show multiplying decimals, comparing the partial products method with a standard algorithm. We're going to do the same multiplication problem twice, and then we're going to throw in an area model for visual understanding here. See if we can make a connection between what's happening and our calculation. Okay. So we're going to focus on partial products first. And what partial products does is it takes into account place value and it breaks it part place value by place value. So for example, the first one I'm going to start with is I'm going to focus on this 400ths by 8/10. And if I have 400ths and I'm multiplying by 8/10, then 4 times 8 is 32, and 100 times 10 is 1,000. Now, to represent this as a decimal, so that I'm back in my partial products here, would be 0.032. This is 32 thousandths. Okay, that takes care of this place value set. Next one I'm going to do is 1 whole by 8/10. Anything by 1, anything times 1 multiplied by 1, it's going to be itself, right? That hasn't changed anything. So that means I'm just going to continue to write 8/10. Okay, the last place value is this 30, because this is not, it's the digit 3, but its value is worth 30. It's in the 10 spot. The tens spot. So what we're looking at is 30. We are looking at 30 times 8/10. Now you can look at this a couple of different ways, right? We can look at it as if I have 30 divided by 10, that would be 3 times 8. So I'm left with 24. Or some people are comfortable multiplying the whole number by the numerator and then simplifying later on by just simply dividing by 10. Anytime you divide by 10, place value moves one place to the right. So let's take a look at what that would look like too. But 3 times 8 is 24, so I'm going to write that so that you guys know what we're doing here. And then the partial products part is done. We just have to add them up. But let's take a look back over here at what I was just saying. So 30. Okay. So 3 times 8 is still 24. But you know this is a 30. So we are going to get 240. 38 sets of 30. So if you count by 30s, 30, 60, 90, 30, 60, 90. It's kind of like that, right? But you get 240 and it's divided by 10. But remember, anytime you divide by 10, the pattern is that it moves to the left one spot. So no matter what you do, no matter whatever way you visualize it, is still 24. Let's come over here and add. So I have just place value by place value by place value. Everything is lined up because we're adding. So 2, 3, 8, and voila. We have the product. We have 24 and 832 thousandths as the result. Okay, and that's partial products. Let's take a look at what the standard algorithm will look like. Right, we'll do the whole thing again, but standard algorithm. And hopefully it won't take up too much of your time. I'm going to actually leave that for a moment for comparison. And then I'll probably have to get rid of it for... well, actually, I'll probably erase the standard algorithm. So let's do that. Okay, standard algorithm is not thinking about place value. Standard algorithm is just looking at the digits and what we know something times something is it, right? Digits. So if I just focus on digits, then right now I'm just focused on those 2 digits, and that's 32. Now I'm just focused on these digits, right? That's 0. 8 times 0 is 0, but we're adding that 3, so 3. Okay, what are the next digits, right? Not place value, just digits. 8 times 1 is 8. 8 times 3, 24. Okay, looks a little different, right? A little different, a little the same. Do you see how these are the same digits? 24832, 24832, but this takes into account the place values, whereas this does not. It's just digits, all right? But we still have 1, 2, 3 place values. So 1, 2, 3, and just like that, you have the same exact answer. Now I think I have the space for our area model, but it's going to get messy. So I think I'm just going to go ahead and, oops. Okay. Okay, let's take a look at what an area model might look like. Now, this problem might not have been the best problem to choose because remember what I said in the beginning, that we didn't have to write the 0. So what's going to happen with the partial product is I will have my 8/10, and you can put it as a decimal or you can make it a fraction 8/10. I'll have that and no holes. And then this one I can break up. This one I can break up into a few. So we'll do 30, we'll do 1, and we'll do 400ths. Now, this is not a perfect representation, but I think you get the idea, right? 30 is much larger than 1, and then we have this 400ths hanging out there. Okay, let's go ahead and take a look at what the areas would be, right? If these are rectangles, we can multiply length by width, and we would get the space inside. Okay. So hopefully this is looking very familiar, right? Because the last step that I did was 30 times 8/10. And when we did 30 times 8/10, the result was 24. We already did 8/10 times 1 as well. That was my second one, right? And when we did that, we got 8/10. Identity here. Will that undo? Okay, good. And then last but not least, it was actually first in my partial products demonstration. We have 400ths times 8/10. And what did we get? We got 32 thousandths. So this is what an area model would look like. And what you would have to still do is add them all up. 24 plus 8/10 plus the 32 thousandths. And we did that already actually over here. So we don't have to do that again because you will just get the same answer. So it doesn't matter what method you choose. You can choose partial products. You can choose area model. You can choose the standard algorithm. And if you have another minute or two to stick around, I can show you one more method. Okay. What if I just don't want to mess with decimals at all? What if I would like to make them whole numbers? We talked about patterns in multiplying and dividing by powers of 10 or multiples of 10. If I'm multiplying by 10, it is moving to the right one time. If I'm multiplying by 100, it is moving to the right twice. That's why I chose 110. 3,104 and an 8. So now what I really have is this. And now you can multiply any way you like. I'll just do the standard algorithm real quick. Okay, and then how do I get back, right? Because remember, I multiplied, I changed my problem. So we have to change it back, right? Otherwise, we've changed the problem because my answer is not supposed to be 24,832, right? We already know what the answer is supposed to be here. 24 and 0.832. Okay, so how do I get back? Well, we have to undo what we did. If we multiplied by 100 and multiplied by 10, it's time to divide by 100 and divide by 10. Well, if I divide by 100, it moves 2 places to the left. If I divide by 10 after that, it moves 1 place to the left. So what does that result? 24.832, like we suspected. The other way you can do this is 100 times 10 is 1,000, and I would still end up having to move this place value 3 to the left, because if you divide by powers of 10, it's getting smaller. Okay, I hope this was helpful once again, and till next time.